Today, we are diving into something truly fascinating, a propulsion system described in an ancient text called the Vaimanika Shastra. Now, on the surface, it sounds like pure mythology. But what happens when you apply modern physics to it? Well, you get a blueprint for a technology that is, frankly, shockingly advanced. So, let's take a look inside. The text actually gives it a name, the Mercury Vortex engine. And yeah, the name sounds like it's straight out of science fiction, but the principles behind it, they're actually grounded in some pretty solid real-world engineering. The real question is, what was this thing designed to do? And that really gets us to the heart of the mystery, doesn't it? Are we looking at a fantastical story, or were the authors trying to describe a pretty sophisticated piece of technology, just using the terms they understood at the time? Could this actually be an ancient blueprint for what we'd call a liquid-state electric powertrain? To even begin to answer that, we have to start with the heart of the engine, its power source. The text describes a system that seems to function less like a simple boiler or furnace and a whole lot more like a revolutionary type of electric motor. Okay, so the whole concept, and I mean everything, hinges on this one principle, Magnetohydrodynamics, or MHD. It sounds super complex, I know, but the idea is actually pretty straightforward. It's just the study of how fluids that can conduct electricity, think liquid metals or plasma, create magnetic fields when they move. This one idea is the key that unlocks this whole design. So what did the ancient text actually say? Well, it talks about heating liquid mercury and then forcing it to spin inside these circular chambers, creating a powerful vortex. Just try to picture that for a second. A glowing, super hot liquid spinning like crazy at the heart of a machine. That is the core concept right there. Now check this out. When you put it side by side with a modern electric motor, the parallels are kind of stunning. A standard motor uses a solid copper rotor spinning around to create a magnetic field. Well, according to MHD principles, this Vimana engine did the exact same thing, but with a spinning vortex of liquid metal. That swirling conductive fluid would generate its own massive, self-sustaining magnetic field. It was, in essence, a liquid metal motor. Okay, so we've got ourselves a motor, a spinning magnetic field, awesome. But how in the world does that create enough thrust to actually lift a vehicle? The next step is where the real power gets unleashed. This quote from our source material explains it perfectly. Once you've got that highly charged, spinning vortex of mercury plasma, you hit it with an electrical discharge. That jolt of energy transfers to the heavy mercury ions and just blasts them out of an exhaust nozzle at incredible speeds. Let's just break that down into 4 simple steps. Step 1, you heat the mercury till it turns into a plasma. Step 2, you spin that plasma to generate the magnetic field. Step 3, you zap it with electricity. And step 4, this accelerates those heavy mercury ions out the back, generating a massive amount of kinetic thrust. It's a really clear, logical process. And if you think this sounds like science fiction, get this. It's the exact same principle behind the ion thrusters that NASA uses right now to propel satellites and deep space probes. The main difference? NASA uses a gas like xenon. This Vimana engine was designed to use much heavier mercury atoms, which would provide way more powerful thrust, especially inside an atmosphere. But you know, power and thrust are only part of the puzzle. Any vehicle that flies has to be stable. And what's truly remarkable about this design is that stability wasn't some add-on. It was built directly into the powertrain itself. Any engineer on the planet will tell you a powerful engine is useless if you can't control it. At high speeds, a vehicle needs a dedicated system to maintain its balance and orientation. You can't just strap a rocket to something and, hope for the best. And the Mercury Vortex engine had one built right in. Just imagine all that heavy liquid mercury spinning at thousands of revolutions per minute right in the center of the vehicle. That motion would create an incredibly powerful gyroscopic effect, a force that resists any change in its orientation. And that right there is precisely how a modern control moment gyroscope works. Spacecraft like the International Space Station use these things to keep their position perfectly steady without constantly having to fire their little thrusters. So the engine in the Vimana wasn't just a motor, it was also the vehicle's central stabilizer. So let's step back for a second and bring all these pieces together. When we stop looking at the engine as separate parts and see it as one integrated system, well, that's when the genius of the design really becomes clear. What we have here isn't just 3 different ideas, it's a complete 3-in-1 engineering system. The principles of magnetohydrodynamics create the motor. That motor then powers an ion propulsion system for thrust, and the entire spinning assembly acts as a massive gyroscope to stabilize the whole chassis. It's just incredibly efficient. So, the takeaway here is crucial. The Mercury Vortex engine, as it's described, wasn't some primitive boiler or fire pit. It was a conceptual blueprint for highly advanced liquid-state electric powertrain, just described using the language and the scientific understanding of its time. And all of this leaves us with one final big question. If a modern engineering analysis can reveal this much sophistication in just one ancient text, it really makes you wonder, what other technologies are out there, hiding in plain sight, just waiting for us to decode them?